And we're back. So we've already dragged age over. You'll see by default that Tukey is selected. And there are times when you can use the Tukey correction, but in psychology, we typically use a Bonferroni um, correction for alpha inflation. So go ahead and click off of Tukey and click on to Bonferroni. Um, and it will pop this up here. Now you'll see effect size here. This is a different type of effect size. This is not relevant to what we're doing here. If you select this, you'll get a Cohen's d, and it might just be confusing more than anything else. So you're welcome to do it and play around with it, take a look. But that is not the effect size that we're interested in or going to need to report. So the way to read this, you'll see there's a comparison between age 5 and 6, between age 5 and 7, and then between age 6 and 7. And tells you what the mean difference is between each of them, the standard error, the degrees of freedom. Here's your t-test. So you'll see here, this is not statistically significant, right? And using our Bonferroni is basically showing there's absolutely nothing there, right? There's absolutely no difference between 5 and 6 once you look at a Bonferroni correction. Now between 6 and 7, this does look like a high t statistic, but again, we're looking at multiple relationships. So what Bonferroni does is it accounts for the fact that we're doing multiple t-tests, and there's an error associated with each individual t-test. And remember, if you've got an alpha of 0.05, that means you have a 1 in 20 chance of making an error. So if you're running 20 t-tests, you're pretty much certain that you're going to end up detecting something by error. So what Bonferroni does is makes it so we don't have to worry about that. It statistically accounts for the number of t-tests that's being run, and you'll see that's why even though this is a high t value, it's not statistically significant, right? It's not below 0.05. But the difference between ages 5 and 7 still is statistically significant, right? That's important. So the next thing we'll take a look at is the estimated marginal means. And this will help you to visually interpret what's going on. But the main thing that matters here is you see a difference between ages 5 and 7, and that is the only difference that you see. The differences between 5 and 6 and 6 and 7 were not statistically significant. That's going to matter for reporting here in a minute.